Good morning, third grade students. We're going to start off our math lesson this morning with a fun math joke. So, my math joke starts like this. Why was the math book so sad? Because it had so many problems. Well, our math books have many problems too. But the problems in our math book are fun and challenging, so we don't need to be sad about having a math book with problems. So let's happily start off our math lesson today. And our math lesson today is going to be problem solving with the area of rectangles. So let's go ahead and see what kind of exciting problems we have in our math book. Okay, all right, so our first problem that we're going to be starting with is about Mr. Coy. Mr. Coy wants to build storage buildings, so he drew plans for the buildings. He wants to know how the areas of the buildings are related. How does the area change from the area of building A to the area of building B? How does the area change from the area of building C to the area of building D? So let's take a look at these buildings. Here we have building A and building B. We want to know how the area changes from A to B. And here we have building C and building D. We want to know how the area changes from building C to building D. Okay, so we're going to use a graphic organizer to help us to solve the problem. So the first thing is, what do we need to find? We need to find how the area will change from A to B and from, remember, how the area will change from rectangle C to rectangle D. Okay, so we need to find how the areas will change from A to B and from C to D. Okay, and what information do I need to use? We are going to need to use the length and the width of each building in order to find its area. So we're going to need to use the length and the width of each building to find its area. So let's take a look at these buildings. Let's just look at building A really quickly. For building A, our length is 3 feet. Our length is always the measurement that's going up and down. So our length is 3 feet, and our width is going to be 4 feet. So our width is always the measurement going from left to right. Okay, so length is how long it is going up and down, and width is how wide it is going from left to right. Okay, so we're going to need to use the length and the width of each building to find its area. Okay, so how will I use the information? I will record the areas in a table, then I will look for a pattern to see how the areas will change. Okay, we're going to see how the areas, see if I can write this okay, doing my best here, how the areas will change. All right, so let's come down and look at our table here. We're going to just look at building A first. So building A, we know has a length of 3 feet, but we need to know what the width is. So what is the width of building A? The width is 4 feet. Okay, so we're going to come back down here and we're going to fill in for building A width of 4 feet. Now, how do we find the area of building A? Well, let's come back up and look at it. Remember, the area is the space inside of this shape. So to find the area, we simply will multiply the width times the length, or we could say the length times the width. So when we multiply 3 times 4 feet, how many feet do we get? We get 12 feet. And we can check by counting how many square feet are in this rectangle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we calculated our area correctly. So we did the length times the width, and we got 12. Let's see, 12 square, we'll just write SQ for square and FT for feet. So the area of building A is 12 square feet. Okay, let's try building B now. Building B, we see here, has a length of 3 feet. So let's find building B. Here's building B. It has a length of 3 feet. Now, what is the width of building B? The width is 8 feet. So we'll go ahead and write in our chart here that the width is 8 feet across. So then remember to find our area. We're going to multiply the length times the width. So 3 feet times 8 feet would be how many feet? That's correct. It would be 24 square feet. Okay, so we did A and B. Now let's quickly do C and D. So we know what the width is for building C. It is 4 feet. So what is the length for building C? Well, here's our width of 4 feet for C, and our length is 6 feet. So we'll come here and we'll write 6 feet. Okay, and so we have building C has a length of 6 feet and a width of 4 feet. So just like we did before, all we need to do is multiply our length times our width. So 6 feet times 4 feet will give us an area of how many square feet? Correct, that would be 24 square feet. Okay, and so next we have building D. Building D we see has a width of 8 feet. So what is the length of building D? Here's our length going up and down. So we take our length, which is 6 feet, and we will write it in, let's see, right over here. Okay, so 6 feet. This also has a length of 6 feet. So we'll take our 6 feet times our width. So we have length times width, 6 times 8 equals 48 square feet. Let's see. My pencil is being difficult. 48 square feet. Okay, so now that we have filled out our chart and filled in our measurement data, what patterns do we notice here between building A and building B? What do you see? And what pattern do you see here between building C and building D? take a look for a minute. Okay, let's go ahead and answer these questions now. I see that the lengths will be the same and the widths will be doubled. The areas will change from 12 to 24, okay? So the areas will change from 12 to 24, and they will change from 24 to 48. Okay, so when the lengths are the same and the widths are doubled, the areas will also be doubled. Okay, so that is a pattern that we discovered. When the lengths are the same and the widths are doubled, our areas will be doubled. And we can see that as we come up here and look at these. The area of rectangle A compared to the area of rectangle B, well, B has twice the area of rectangle A, and D also has twice the area of rectangle C. Okay, well, good luck on your homework assignment, and please remember to contact your teacher if you have questions. And thank you for working hard.